Hey, welcome back to our series on Facebook LeetCode interview questions. We're going through the most frequent LeetCode interview questions according to LeetCode on LeetCode in the past 6 months according to LeetCode. All the LeetCode, and that is what we're going to do. So today we are tackling a new question, number 408, a premium question. Hello, Mr. Big Bucks over here. Yeah, I'm investing in you guys. So what this is a valid word abbreviation. So a string can be abbreviated by replacing any number of non-adjacent, non-empty substrings with their lengths. The lengths should not have leading zeros. Okay, very good. For example, a string such as substitution, haha, I see what they're doing there, could be abbreviated as, but not limited to, S10N, where this 10 represents the 10 letters between S and N. We also have sub4U4, where 4 represents STIT, and this 4 also represents the TION, and then it could just be 12, the entire length of substitution. We also get a little crazy where we have 3s and 2s and so on. 1 here, a 3, a 1, a 2. It can be any number. Could also just have no abbreviation at all. It could just be substitution is equal to substitution. Pretty crazy, pretty fun. And then here we go, not valid. We have 5, 5. You can't do 5 and 5 because it would be 55. That's how we would treat that. Here we have a leading 0, so that doesn't work. And then here, you can't substitute with a 0. So anytime we come across 0 as our first number, that's automatically a red flag. That's one of the key parts here. So what we want to do is we have our word and we have our abbreviation. So this is going to be a pointer question. So we need a pointer for both our word and our abbreviation. So let our word pointer, we'll call it WP, then we'll set that to 0. We'll let our abbreviation pointer, we'll set that to 0 as well. And then we also need to keep track of what our current number is. So basically, when we come across as 5, we need to check if there's another number behind it. If there is, the new number is 55. So we'll say let our current number, we're going to set that to 0 as well, because we are starting at 0. And then what's going to happen is we're going to go through a while loop. So we're going to make sure our word pointer is less than our word length. Yeah, pretty straightforward. So we'll go, while our word pointer is less than our word.length. Very easy. So we're looping through this whole word because in a perfect world, this will always be longer than the abbreviation. And then what we want to do first is check our abbreviation. So if our abbreviation at our AP, so that's what we're looking for, but what are we looking for exactly? We're looking to see if it is not a number, or not a number to be exactly. What we're looking for is to check if it is a number. So if it is not a number, I know, a little crazy, but that's what we do in JavaScript. So if it is not a number, meaning it is a number, what are we going to do here? What we want to do is say current number, and what we're going to do is get our current number times 10, and we're going to add the number at that. So we're going to say current number is equal to current number times 10, and we're also going to add our number version. So we're turning this string number into a number at abbreviation at AP. Our AP is our abbreviation pointer. And then what we also want to do is now check to see if it was a leading 0. So if our current number is equal to 0, that's a big no-no. What we're going to do is return false. So what this does is we check, we add it, and then we add it to this. So if it is 0, that means the previous number was 0, and this number is 0. So that would be a leading 0. So if the current number is now 0, we're going to return false. So that is automatically one of our not valid abbreviation situations. So we'll do that. And then, of course, we want to increment our abbreviation pointer. Else, if what we want to do is say if our current number is greater than 0, so that means we have found the full number. So the current abbreviation pointer, for example, we'll come over here. We'll do this. So, we'll do this and this. So basically what would happen is, let's grab one of our smaller words. So apple, here we go. Apple, put that there. And then our false abbreviation is A to E. So we'll put that here. So basically we have our A pointer here, or sorry, our W pointer there, and our A pointer here. So what we do is we first check it'd be better if we're, hold on, we'll get back to that. So if they're both if they're both the same, we'll go ahead and do that. So else if, sorry, my brain's not working today. The abbreviation at AP is equal to our word at word pointer. What we want to do is go ahead and increment both of those. AP is incremented and word pointer is incremented as well. So basically that takes care of this one. So yes, they're both equal to each other. So then word pointer moves forward, abbreviation pointer moves forward, and then we hit line 19 to 22. So the abbreviation pointer is at 2. That is not a number, it is a number. So what we do is we update our current number. So that would be 0 times 10, which would be 0 plus our number version of that. So it would be 2. And then we go ahead and move our pointer forward, and we get this A at this E, and then boom. This is not true anymore, but now our current number is greater than 0. So what do we want to do here? What we want to do is go ahead and say our word pointer is plus equal to our current number, because that represents how far ahead we want to move ahead. And then we also want to reset our current number. Current number is now equal to 0. So we move ahead by current number places. So we go 1, 2. This is now a 0, and boom, we have L and E. They're not equal. Current number is not 0, is not greater than 0, and the AP is not pointing there. So that is our final case, which would be returning false. Pretty cool. And then yeah, that is a quick way to do that. And then of course we want to make sure that we need to check in case there is a number at the end. So basically what we want to do is say we want to return AP is equal to our abbreviation length. So it's at the end, and our WP plus our current number is equal to our word.length. So this takes into account getting to the end. So this one here, this part here, this checks to see if there are any remaining characters in the abbreviation that we didn't get to, which would mean that the abbreviation is longer than the word. So that would be false if it is not true. And then here we also want to check this part here. So our word pointer plus our current number. So that is the remaining numbers that we didn't get to add in this case here. And then we add it, go ahead and then check if it's equal to the word length. Let's go ahead and run it. Please pass. We pass. All right, and then let's submit it. And we do quite well. Hey, 91 and 64. Very good. Anyways, that's how you do question number 408, a valid word abbreviation. If you have any questions, feel free to let me know. And then as far as our time and space complexity, all we do is we loop through O of n, where n is the number of letters in word. Very cool. And then we also have space complexity, O of 1, O of 1, O of 1, and O of 1. So O of 1 space complexity and O of n, where n is the number of characters in word. Yeah, that's it. Thank you so much. Have a great day. Catch you later.